Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics and question number 1 which belongs to paper 9709/42 for the session May June 24. Let's see what question number 1 says. Question number 1 says a cyclist and bicycle have a total mass of 72 kg. The cyclist rides along a horizontal road against a total resistance force of 28 Newton. Find the total work done by the cyclist to increase his speed from 8 meter per second to 16 meter per second while traveling a distance of 100 meters. So it is one of the simplest and easiest questions because they have already told us indirectly advised us to apply the concept of the work energy equation. How? Look at this, they have already given us and instructed us to find the total energy. Okay, total work should be obtained, and we know that from work energy equation easily we can find the total work done by the cyclist. So let's start applying the concept. The concept of work energy equation is work done by driving force minus work done by resistance force is equal to change in GPE plus change in KE, means kinetic energy. That means change in gravitational potential energy as well as change in kinetic energy. So work done by driving force is to be obtained, so let it remain unchanged, minus work done by resistance force. You know, the formula of work is actually force into displacement. So let us write that means resistance force into the displacement, and change in GPE is actually mgh plus change in Ke, kinetic energy, is equal to half of mass into v squared. So let the left side remain unchanged because we are going to find work done by driving force equal to then force into displacement. That means resistance force, which has already been given, that the cyclist rides along a horizontal road against a total resistance force is given. So total resistance force is 28, and displacement of the cyclist is while traveling 100 meters. This is the displacement, means distance 100 meter, plus mgh. M indicates mass of the cyclist, which is 72. G stands for acceleration due to gravity, which is 10. Now h is actually change of height, difference between final height and initial height. If we go through the question, a cyclist and bicycle have a total mass of 72 kg. The cyclist rides along a horizontal road. Along a horizontal road. That means there is no change in height, and our change in GP is always based on difference of height. As there is no difference between the final and initial height, so it is nothing but 0, plus half of mass is 72, and v square. Remember, while you write the v square applying work energy equation, g h, and look at this h as well as v, these are actually difference between the two heights, means final and initial height, as well as difference between the final velocity and initial velocity. So it is actually difference. H is also indicates the difference in heights. Velocity also indicates difference between final velocity and initial velocity. So let's see how much was the final velocity given in the question. Final velocity is given. How much is the final velocity given? Final velocity was 16, so it is going to be 16 squared minus initial velocity was 8 meter per second, 8 squared. Okay, then Hence, our work done by driving force is nothing but work done by driving force. Work done by driving force is equal to, this is 2800. 2800 plus, if we divide 72 by 2, it is 36. So 36 into here 16 square means 256. 256 minus 64 is equal to nothing but 192. 192. Hence, work done by driving force is nothing but 2800 plus 36 into 192 means 9712. 9712 joule. This is what they have told us to find. That is the answer. I think you have understood this solution, because this is one of the easiest and simplest of all solution of mechanics. Let's move on to the immediate next question. The next question is question number 2. Question number 2 is, a particle P moves in a straight line at time t second after leaving a point O on the line. P has velocity v meter per second, where v is equal to 44t minus 6t square minus 36. Find the set of values of t for which the acceleration of the particle is positive. So here the concept is, they have given us v, okay, and we know acceleration from the expression of velocity is nothing but the derivative. So we will have to find the derivative. Let's write v is equal to, v is equal to what? Let it be arranged in ascending order, negative descending order. 6t squared plus 44t minus 36. So for acceleration from velocity, we just find the derivative. So dv over dt is equal to, here negative 12, 6 to the 12 t plus 44, and derivative of any constant number is 0. So they have told that acceleration should be, hence a is equal to negative 12t plus 44. Now they have told to find the value of t, time, when acceleration was positive. Acceleration was positive means a is greater than 0. So when, let us write just beside this, it is going to be, our a is greater than 0. So how much was our a? I mean expression was negative 12t plus 44. So let us write negative 12t, or negative 12t plus 44 is greater than 0, because it is supposed to be positive. Then if we transpose this 44 to the other side, it is going to be negative 12t greater than negative 44. If we multiply both sides by any negative quantity, the symbol of inequality is going to be interchanged. It is going to be less than 44. Negative 12t is, so you know this inequality symbol gets changed when you multiply both sides by any negative quantity. Hence our t is going to be greater than 44 over 12 means 11 over, sorry, not greater than, it is going to be less than, t is less than, t is less than 11 over 3. 3 4 is 12. That is the answer. That means when the time is more than 11 over 3 seconds, then the acceleration was positive. Okay, that is what the answer to question number A is. Let's move on to question number B. Question number B says, find two values of t at which p returns to O. So suppose this is a scenario. Okay, no, I don't want to draw over here. Let me show you. This is our this is 0. This is our velocity v meter per second, v meter per second, and this is t second. Well, and it is, this is quadratic. Velocity is here a quadratic graph, and as it is negative, look at this, our graph is negative. Look at this, because highest degree is negative. So minus 6t square, when t is 0, our velocity is negative. That means it should start from the third quadrant. If it starts, suppose here there is negative 36, isn't it? It is negative 36. So the curve just from here, curve went up, and it just go up and went down. Now they have told us to find that the values of two values of t when p returns to O. Okay, when p returns to O, remember there may be a scope of confusion that when p returns to O, velocity is not zero at all. Rather, displacement is zero. That means the particle. Suppose this is the particle, yes, particle moving at this direction from O, here is O. If it returns to O, then definitely displacement is zero. So I think you got my point that when particle is at O, displacement is zero, velocity is not at zero. That is, this is the point. At this point, displacement is zero. So from the expression of velocity, we will have to write the displacement. Our velocity was, what was the expression of velocity was, v was negative 6t squared, negative 6t squared plus 44t plus 44t minus 36. This is the expression. Let us see whether we are correct or not. Yes, this one is the expression, is negative 6t square minus plus 44t minus 36 is our expression of velocity. Now we are to find the displacement, what is zero. Okay, so for displacement we will have to just integrate the velocity. Let us integrate v in terms of time, v dt equal to, if we integrate this, the power will get increased, so it is going to be 3 negative 6 over 3, then power will increase by 1 3, plus here also power will increase by 2, so 44 divided by 2, then t, if power increases by 1 it is t square, minus if power increases it is 36t, then plus c, constant number, plus c, plus c. Well, after that, okay, then we know integration of velocity is nothing but displacement. So displacement is denoted by s. S is equal to, if we calculate here, it is negative 2t cube plus, if we divide 44 by 2, it is going to be 22t squared minus 36t plus c. Now look at this, at the beginning when t was 0, displacement was also 0, so actually c carries no weight, there is no constant number. S is equal to negative 2t cube, negative 2t cube plus 22t squared minus 36t. There is no constant value for the expression of displacement. Now they have told that when p returns to 0, when p returns to O, not 0, when p returns to O, s is equal to 0. So let us write this, at O, at O, s is equal to 0. So if s is equal to 0, we have already obtained the expression of s. This is the expression of This is the expression of s. That means negative 2t cube plus 22t square minus 36t equals 0. Now among these expression we can take t as common. 2t can be taken as common. If 2t is taken common, it is going to be negative 2t goes away, so this is t square minus 11t minus 18 2s are plus 18 2s are 36. Now you may ask, how can we ignore t is equal to 0? Actually, t is equal to 0 at the beginning. At the beginning, look at this. At the beginning, displacement was 0. It was at O. So this is not necessary. They have told to find the other two values, raise two values when again p returns to O. So 0 time, and when t was 0, we know that p was at O. Now that value is unnecessary for us to obtain. They have told us to find the rest two values when p again at O. P was again at O, so we can write here, if we expand this, it is going to be t square minus 9 2s are 18. Yes, 90 minus 2t plus 18 is equal to 0. If we take t common, it is going to be t minus 9, and another factor is going to be t minus 2. If 2 is taken common, it will be t minus 10 equal to 0. Hence, our time is going to be 2 as well as 9. So at t equal to 2 and at t equal to 9, the acceleration, the particle was at O again. So this is what the answer should be. So what did we do here? The concept we have applied when the particle is at O, that means at the beginning, at the initial stage of the movement, then the displacement will be 0. So displacement is actually nothing but the integration of velocity. Remember, the confusion may arise is sometimes the students start v equal to 0 in such case. No, velocity is not 0 at O. They didn't mention that second times when it returns to O, the velocity was 0. It was velocity gets 0 when the particle is at instantaneous rest. They didn't mention that the particle was rest. They told it was in motion, but it returns back to O frequently. So in this case, at O, displacement is 0, but the particle was in motion. It was not at instantaneous rest. That's why displacement was 0, and the displacement is nothing but the integration of velocity. But derivative of velocity is acceleration. We are not doing anything about acceleration. It's all about displacement. So displacement is the integration of velocity. So thank you all for watching the video. Let's solve the next question, question number 3. And I'm going to solve the next question in the next video, inshallah. Fi amanillah.